The subject of today's video are these servo motors and why do they behave erratically. Okay, so the first thing we need to know is how do these servo motors get their information. So let's turn this on. Let's turn our oscilloscope on and see what we got. So what we're looking at is the output from the servo signal. I hear you, Henry. Henry's going to be joining us shortly. Okay, so, and right here, you probably can't see that, but it says time, which is the time of this pulse, is 2.5 milliseconds. If we turn it all the way down to 0, now I know you can't see that, what we have is 0.5 milliseconds. Excuse me, kitty. So that is basically how the servo knows that which angle to go to. So 0 is equated with a half a millisecond pulse width, and go all the way around, 180 is equivalent to 2.5 millisecond pulse. And what that means, of course, is that at the 90-degree mark, it's 1.5 milliseconds wide. So now, the problem that we run into is that the specifications, if you get these off the internet, the specifications for these SG90 servos says that the mid position is 1.5 milliseconds, just as we saw, but the 0, or that 180, should be doing a little bowling there, Henry. Thank you very much. Alright, so at 2 milliseconds, it's supposed to be 180 degrees, and at 1 millisecond, it's supposed to be 0 degrees. So the specifications do not agree with at least what this is doing, this servo tester. Let's plug a servo in and see how we're going here. Okay, that's all the way around. Let's turn this. Oh wait, that's 90 degrees. So that's 0.5 millisecond pulse width. And the servo goes to this position. 2.5 millisecond pulse width, and the servo goes to that position. 1.5 right in the middle. So already we are seeing that here is 2, and it's not all the way over. And here, let's go to 1. It's not all the way around either. So this specification, go be ashamed. It's not right. So most of the servos that we're going to get are actually 0.5 to 2.5, with 1.5 being the center. So these servos that we order, where they come in a bag with no instructions at all, are probably going to be that specification. Let's look at another one. Let's look at one of these big ones. Okay, there's one side. Here's the other. There's the middle. So as you can see, and what I've seen online is that most servos seem to be, if they have specifications, and you can get them, like if you go to Amazon and you find a servo that actually comes with a set of specifications, it says it's 0.5 to 2.5. The ones I have here that came without any documentation are 0.5 to 2.5. And most software that I've looked at, the firmware, is set up as the default, 0.5 to 2.5. So I think we can say that it's 0.5 to 2.5 gives you 0 to 180 if you can produce that. Okay, so switch this off. Now, the first thing we've noticed is that this particular test board produces exactly the right pulse width. How will our expansion boards do, though, with our microbit? Let's try some. Let's put that aside. And let's bring up, this is from Key Studio, and I'm just using this to get to the I2C, and I'm using this PCA 9685 board. So let's hook that up and see how it does. Hello, Henry. You're back? You're back for more cuddles, are you? All right. How are you? Did you want to go outside or something? What's up? Yep. You want me to open the door for you? All right, now. All right, let's turn it on. What do we got? So at 90 degrees, we're getting 1.49. That's actually pretty good. That's pretty close to what it should be. Let's go to 0. 0.47. That's good too. That'll get us all the way to 0. Let's go to 180. 180 degrees, 2.34. So what we're seeing is that this is not going to turn our servo all the way around. Let's connect one of our servos. Excuse me. And as you can see, it's not all the way around. Let's see if you can see that. It's not all the way around. So when we go to 0, it goes all the way around to 0. When we go to 90 degrees, that's both buttons pushed, it goes to halfway. But when we go to 180, it only turns part way. That's because it's not getting all the way to a 2.5 millisecond pulse width. Now, supposedly we can change some of the parameters on this board, and I haven't tried that yet. I tried doing it with the extension I'm using, but that didn't seem to actually change anything on this board, so I'm going to have to dig into that. But as you can see, that's not going to give us the entire range. But it will give us something close. Remember, it was at 1.49, which is close to the center. 0.47 will give us all the way to 0. We just don't get the benefit of getting all 180 degrees from it. Let's try a different board. Let's try one of these DF Robot microbit driver expansion boards. And let's hook this up to our oscilloscope. And for this board, I'm using 5-volt input. Switch it on. 1.46 or 7. 1.46, 1.47, switching back and forth. So stabilized at about 1.46 milliseconds. So it's not exactly centered. It's a little bit off. Let's go to one side or the other. 2.33. So again, this isn't going to turn our servo all the way around to 180 degrees. Let's see what the 0 has. 0 is at 0.58. So it's not going to go to 0 either. So center isn't exactly center, although it is close. And we're missing out a little bit of the 0 and a chunk of the going to 180. Let's see what happens if we use a different, identical, different board. So this is from the same manufacturer, DF Robot. Let's see how this one does. Switch it on. It's our 1.44. So that's not the same. The previous board was 1.46. This one is 1.44. That's not the same. So there is some variability within the electronics for these boards. 2.3 is all the way at the top. I believe that's the same as we had. Let's go to the bottom. 0.57. That's a little different. So it's similar. You are going to miss out some of the range, but the center is a little bit different. So if you were building something that relies on servos and you swapped from this board to that board, even though they look identical, the servos would behave slightly different. Probably not a lot, but slightly different. And depending on how sensitive your needs are, that could make a difference. So these two boards are not exactly identical. Let's try some other things. Let's go to the robot category. Alright, so now this one is a Kitronix move motor. Let's hook up the ground. Let's hook up the servo. Now this one says that pin 16 from the microbit itself is what's being used to trigger the movement. So the PWM signal, pulse width modulation, is coming from pin 16 on this board. Okay, there you have it. 1.48 is our center. That's pretty close to the 1.5 it needs to be. Push the button. 2.50. So that is exactly what we need to get the full range. Let's go to 0. .48. So that's going to give us a full range. Let's look at that for a second. Let's turn this off. Let's connect up a motor. Turn it back on. Alright, so there's our center position. Go to 0. There's 0. Let's go to 180. 180. So this gives us the full range of motion. And that's probably because we're actually using the PWM signal from the microbit itself. So it's not using a secondary chip like, say, this, where we're using a chip on this breadboard. So it's not using a secondary chip. And I would imagine that these DF robots are also using a secondary chip because we've got 8 servos. So probably using a different chip. Okay. Let's turn this off. Let's try a different one. Let's try, now, I had a problem with my ElecFreaks Wukong board, but I really like the ElecFreaks CuteBot Pro. So, just putting that out there. Okay, so servo, let's hook up our servo. And this one, the blue wire, is the signal. Thank you, Kitty, for running into me. Okay. Let's turn this on. Excuse me. All right. So let's see what we got. All right. So the halfway mark, 90 degrees, is 1.51. So again, very close to what we want it to be the center of the servo. Let's choose one of the sides. 2.5. Excellent. Let's look at 0. 0.52. Pretty good. So this is pretty good. Not exact, but probably good enough for what we need. Let's try that with the servo. I'm going to turn him off. Turn it on. There's 90. Zero. 180. We can get the full range of motion with the CuteBot Pro. So far, as I said, I'm pretty impressed with this particular robot. And let's get out our trusty Queen Plus version 2. Now, this robot has 3 servos, and they're connected to pins 0, 1, and 2. Let's connect it up and see what the range on that is. Alrighty, turn them on. Go. 1.48 is the center. That's not bad. That's pretty good. .5. That's pretty good as well. And go to 0.48. Now again, this, like the Kitronics, is using an actual pin. I'm not sure if this uses pins for servos. I'm going to have to look that up. Does this use a microbit, or does it produce its own PWM? I don't know. But I know for sure that the McQueen does. So that's why we're seeing such a good range there. And it only uses 3 because the original microbit didn't have a good handle on PWM. 3 was pretty much the most you could do. Oops, it's still turned on. Alright, let's try that. Let's go to the center. Go to one side, go to the other side. So, McQueen Plus version 2, you've only got 3 servo outlets, and they use pins 0, 1, and 2 to do it. So that means that if you're going to put all 3 servos, you can't use pin 0 for sound. So it's got, basically it's got 2, well, it uses, don't eat that, it's using the PWM from the microbit, and that does have limitations on it, especially in the older microbit. The newer microbits, I believe they're capable of running 4 servos, but you have to give up sound because the sound system uses the PWM hardware to produce sound, and you're also trying to use the PWM hardware to move servos. That won't work. You can only use it for one or the other. Notice that with the move motor, we've got our 2 servos connected to pins 15 and 16, which gets us around that problem. So we can use sound and 2 servos with this. Okay, what else should we look at? Let's look at voltages. Let's turn this guy off. Turn this guy off. And I'm going to go back here to this. And I'm going to unjumper the 5 volts. And I'm going to switch this plug to this. And let's look at this. So this power supply is able to use different voltages. It's got 3, 4.5, 5, and 6. So let's see how that works. So let's first start out, well, let's start out with 5. We'll test that to see if it's really 5. So this has, right now it has voltage to it. So I'm going to unplug that until I get it plugged in here. So there's ground, and here is positive, and I'm using this to power this chip, and we're going to connect up a servo. We're going to use one of the small ones. See how that goes. Okay, so as we saw before, at 5 volts, no problem. It's quite reliable. Let's check that voltage. So this is now set to auto. So we'll be able to see what voltage we get. This has a kickstand. Alright, so I'm going to put this on the pins. Let's see what we've got. .1 and a 6, 5.16 or so. So that at that voltage, our servos work quite well. Alright, so let's unplug this. And let's change this now to 4.5 volts. See how well it does. Alright, powering it back up. Let's check the voltage. .6. And let's check the servo. Okay, so that's still pretty good. Alright, let's go down a voltage. Let's go down to 3 volts. Power's on. Check the voltage. 3.3. Oh, that's actually 3.3 volts. This might still run the servo correctly. Let's try that. Nope. I can feel it trying, but it's not going. Nope. It says no. I am not doing that. No, sir, I don't like that. All right. Let's turn this off. So, voltage does matter. So, and as we saw on the voltmeter, let's take this off. I don't like it grinding away. Still might want to use that someday. You have to have more than 3.3 volts. Let's check the voltage that's coming out of our microbit, that's running the microbit. How did you get switched to ohm? It's tricky. That seems wrong, doesn't it? Let's do this differently. I'll turn that off, and I'm going to power this from the top. Power this directly from the microbit. Microbit power. Let's see what we're getting. .3. So the voltage that runs our microbit is 3.3 volts. So that means that if you are purely running from the microbit's power, the 3.3 volt pin, it's probably not going to work, at least this particular servo that I've bought. Now there may be some servos that will work with as low a voltage as 3.3 volts, but this is not one of them. Let's try a different. .0 degrees, 180 degrees, not even budging. Okay, again. Make sure it's actually got that voltage. Oops, not there, over here. 3.3. So as you can see, the voltage makes a difference. You can't just run it straight off of whatever the microbit 3-volt pin happens to be. It's just not enough to run many of these. Like I said, there may be some that run at lower voltages. Be careful when you buy your servos if you want to use them at 3.3 volts. Let's try another servo. It's a different servo. This one came in a kit, and it is a SG90. The ones we were looking at were MG90S, which are slightly different. Get that plugged in. Okay, we're at 3.3 volts. Nope, not going to do it. Even though right on the outside, you can see it maybe, it says 3.3 volts / 5 volts. But we're applying 3.3 volts to it. Let's make sure. Nope, I unplugged it. I lied. Let's plug it in. There it goes to 0, back to 180. Okay, well, kind of sort of 180, but we already looked at that. So this servo is rated for 3.3 volts, and it will work at 3.3 volts. So you can use this servo plugged into the microbit pins directly, but you cannot use this servo. So they're different. Okay, so that's our kind of investigation of servos and all that for today. Thank you for watching. I hope you learned something useful, and see you next time.